Hello, everyone. My name is Daniel Keelback. I'm the chair of Climate Action Edmonton. We're an organization dedicated to the Retrofit Canada project. Welcome to our inaugural webinar. We're really happy to have Peter presenting today. Our organization is a collaboration of multiple organizations from across Canada, and our mission is to provide open source access to information about deep energy retrofits, how they work, how to do them, and to teach homeowners the benefits of deep energy retrofits. Today, our presenter is also one of our board members and founders. Peter Amarangan is one of the fathers of net zero energy construction in Canada. Peter's 45-plus year career in construction has been celebrated with awards and accolades for his many accomplishments in the high-performance building sector. Peter is an inexhaustible collaborator, sitting on the boards of numerous nonprofits and presenting at conferences across the continent. At present, Peter is a partner with Butterwick Projects and is leading the deep energy retrofit of the 59-unit Sundance Housing Co-op. These are, along with many other things that Peter has going on. I'll pass over the conversation and presentation to Peter now. Seems like quite a few people are still popping in, so do you want to jump right in, Peter, or do we want to wait?
I'll jump right in. I guess I was sharing my screen. I'll get that back. Holy mackerel. Yeah. So thanks, Daniel, and hi, everybody. I have been building for a long time, worried about energy efficiency since the 1970s oil crisis, and have just recently woken up to the climate emergency and the problem with existing buildings. I really like the Bill Gates bathtub analogy. You know, the total limit on how much CO2 and other GHGs that we can emit without inviting catastrophe. This is a graph showing how fast Edmonton needs to bring down its GHGs to be in line with a 1.5 degree scenario. We're nowhere near where we need to be. Remember, it's the area under the curve, the water in the tub that counts. If we wait 20 years before making deep cuts, it'll be way too late. In fact, at the rate we're going, Edmonton will have blown through its GHG budget in 8 years. I mean, actually 6, really. This is a 2-year-old slide. And we're not alone. These graphs look pretty similar all over the industrialized world. Buildings are responsible for about 40% of total GHGs. Most of that is from building operation. And 70 to 80% of these buildings that we'll be using in 2050 are already built. So there's just no path to a stable climate without industrial deep energy retrofits. And when we say deep energy retrofits, you know, I mean energy retrofits to buildings that reduce the emissions enough that the remainder can be gotten from zero emission sources. So there's some discussion in the community about whether there should be deep energy retrofits or whether we should just call them deep retrofits to encompass things like embodied carbon and that kind of thing. But it's a really curious juncture, you know, a profound challenge, and I think unprecedented in human existence. Our culture of building huts evolved slowly over millennia. We got really good at sheltering from the elements and making spaces where our families can thrive. It seems like such a rude shock to find out that these shelters are threatening our very existence. It just seems ironic as all get out. And the scale is really frightening. This is just Edmonton. And the link in the below the photo is to an article that showed up in the Guardian just yesterday about how Europe is scrambling with the very same problem. The folks that we kind of look to as leaders are having this same wake-up call. So we need an industry. We need a massive industry. And a couple of months ago, I was on a call with Ralph Torrey, a really smart consultant working on a retrofit strategy for Efficiency Canada, which is a think tank in Ottawa dedicated to accelerating energy efficiency policy in the country. So Ralph asked me, I'm a little one at a time builder renovator. What would I do if I had 5,000 or 6,000 houses to do? And it was kind of a shocking wake-up call. I really hadn't thought about that scale before, but that's really what we need to do. So I started thinking about what are the ingredients we need to make this kind of a massive shift. And obviously we need market demand. There needs to be a value proposition, skilled workforce, supply chain, which I don't think would be a big problem, and all kinds of solutions to handle the wide variety of problems. So the value proposition, partly from the energy efficiency, the energy savings, but that's not enough to pay for this. Some of it will come from the exterior upgrade, looking after avoided maintenance and renewal that's necessary. Anyway, enhanced durability, we can make these buildings last a lot longer, and subsidies and incentives. And when we roll these all together, they can result in a lower total cost of ownership rather than a short-term payback that starts to make sense. And the bonus is that with these things come enhanced appearance and resale value, way better comfort and higher indoor air quality, and the peace of mind that lets you look your kids in the eye, and tell them our family's doing what it can. So the skilled workforce is an enormous challenge. We need energy modelers who understand optimizing net zero energy solutions. There are a few of them, but there are a whole bunch that need to be retrained to learn that. We need designers who get it and build it into their designs from the beginning. We need really inventive renovation contractors who understand and practice airtight and thermal bridge-free construction, and an army of skilled tradespeople. Talk about a job creation program. And in this training, passive house training is a huge asset. And we need solutions. We need a set of solutions and recipes that are flexible enough to deal with the incredible diversity of buildings that we have in different housing types, shapes, ages, conditions, climate zones, all that stuff. We need all kinds of repetition and practice. We need to get going and do this stuff and streamline those solutions. And we need to document and share lessons so that we can learn from each other as quickly as possible. And one thing we can't do is continue with incremental piecemeal retrofits. The kind that very well-intentioned efficiency programs have been incenting for the last 50 years or so. The problem is that the measures that get done under these programs often make it much more difficult to ever get that building to a near zero carbon solution, to a net zero solution. They do save energy and GHGs, but most of the time they lock in the remaining emissions from that building. So, for example, adding insulation to an attic without doing anything about airtightness. often that insulation, and we'll see in an example further on, needs to be removed to make that airtight. And the additional the energy savings from the extra insulation are very often less than the amount of energy lost from the leakage in the first place. Another example would be adding too little insulation under new siding. So, the siding's a big expense, the money is gone, and we really need that for the comprehensive solution. So we need, and same with windows. The windows might be better than the ones that are being replaced, but not enough better, and not installed in a way that knits together with an airtight, heavily insulated envelope. So it's sad. As I say, these things are usually done by people with the very best intentions, wanting to do the right thing. So so very much like building new net zero energy houses, it works way better when you start with net zero as a starting point. And I'm going to take you through a couple of examples, successful examples that show the breadth of the range of solutions that are necessary. This one is a deep energy retrofit of a semi-bungalow in Ritchie in Edmonton, 1947s. It was a perfect candidate. It needed everything. It needed new siding, new roofing, and new windows. And in fact, the inside needed to be gutted as well. It was very low cost, and the deep energy retrofit, which reduced its total energy load by 80% and brought it into net zero territory, made a lot of sense. It was and we'll look at a few of the details in some of the other slides. So that's one end of the scale. The other end would be something like this duplex in Riverdale, which just happens to be where I am right now. I built this in around the year 2000 to the at that time R2000 standard. So it's got decent insulation, reasonably airtight, fairly good windows. It's in really good condition, and it doesn't make, it wouldn't be cost effective to do an exterior deep retrofit to it, because the upside would be too small and the cost would be huge, especially since it's kind of a rangy house with lots of windows. I mean, to think that 3 years later the climate crisis dawned on me, it's embarrassing. But anyway, the solution in this project is to do the easy stuff, add a little bit of insulation to the attic, which is just a matter of blowing a little more cellulose, change out the glass in the windows to state-of-the-art glass. The frames are decent, and do a geothermal system, which we're going to try and do as sort of a pioneering directionally drilled laparoscopic geothermal system. So, it's a broad range. There's really everything in between. We need a recipe book to help guide folks. And I'm going to show you a few of the measures that we're using, and use a couple of current projects to illustrate those. One of them is the deep energy retrofit of the Sundance Housing Co-op. This is a 1970s 59 unit townhouse project, 15 buildings. And we're using a panelized retrofit system. We're doing it with some help from Enercan as an R&D project, and it will be it is the first large-scale trial of the Dutch energy sprong system. Look it up. I don't want to take the time to describe it right now, but we're proud to be kind of pioneering this technology in North America. We're on our 7th building, so we're getting the hang of it. So it's going slower than we'd hoped, for all the cool stuff like the digital capture and the offsite panelization. The grim reality is that this is exacting renovation work with all the finicky detail that implies. The good news is that as we go from building to building and run into these tricky little problems, we're finding better and faster ways to deal with the weird anomalies. We're learning a ton, and this is all will all be available on the Retrofit Canada website. The other project is 3 single-family houses that where we're going to try to use what we're learning on the Sundance project and apply it to single-family houses. The GHG impact from Canada's 8 million single-family houses is far bigger in total and per capita than it is for the multifamily buildings. And this is a problem that it urgently needs solving. So we will be doing these 3 houses over the next building season. We're gearing up. We've got it pretty much figured out now, and we will be sharing those solutions as well. So let's look at some of those particular things. And I mean, the first thing is that don't even think about tackling a retrofit without starting with an energy model. You're shooting in the dark otherwise. You really need to start with an existing energy model and then sort of twirl the dials and look at the cost benefits of each measure to find the right mixture for that building, so that you're not putting way too much insulation in one place and not enough in another. The starting, at the bottom, we've got a variety of foundation insulation solutions in the Ritchie project that I showed you. They insulated on the inside. That can be very difficult if the basement is finished and too expensive to be practical. Typically, this is a less expensive approach if the basement is pretty unfinished. One of the bonuses over the outside approach is that you get the opportunity to insulate the floor too, which is a big boost and kind of a sore point for me. I'm talking to you from my basement office with its uninsulated floor, and it's a daily reminder of how easy it could have been to avoid this problem. On the outside, you're always going to have to do some kind of excavation. Porches and sidewalks can be a barrier, but it can be an opportunity to fix weeping tile if that's needed. And it's typically going to be more expensive. On the Sundance project, we started by doing a full excavation with a mini backhoe, and it was a nightmare of disruption, and we had to completely re-landscape, and we had mud everywhere and settling, and so we've gone to a system where we hydrovac a slot around the exterior and then drop in EPS foam, and then top off the sort of wear layer with our panel support system. And these details will be available. I'm not going to go into them in too much depth, but they're readily available for anybody who's interested. We're liking that system, and we have an improvement on the way with it. And we'll be doing the hydrovac solution on the 3 SSRA houses, except for one which needs weeping tile. So the exterior walls, there are a few ways to go about it. Doing it on the exterior as opposed to the interior seems to be the only practical way. Working on the inside, there's far too much stuff in the way: partitions, floors, cabinets. There's the issue of the loss of interior space and the difficulty of getting any level of airtightness. So generally, the solution is going to be work from the outside. On the Ritchie house, we did a very light frame build up on a sort of a panel support box at grade. Wrapped the whole house first in a poly vapor barrier, that ended up on the warm side, and then insulated inside the framing, and then put the new siding over that. One of the good things is on the outside, you can afford it doesn't cost much more to go thicker, so you can accommodate high R values. If you add a rain screen, it can be extremely durable. And with, as opposed to the panelized approach, which I'll get to in a second, this sort of site-built approach is easier. It takes more work. It's more labor intensive. It takes longer, more disruptive, but you just build to what's there. It's harder to make a mistake. Yeah, and so an interesting approach that Peter Darlington from Solar Homes in Calgary is using with great success is to he comes at this as a stucco contractor, and he figured out, starting with his own house, that he could make it net zero by thickening the foam enough. The airtightness was already coming as part of the exterior insulation system, but there's a barrier that gets rolled onto the existing framing. All he had to do was knit it into the attic, increase the attic insulation, and somehow deal with the foundation. I'm not sure, but this is quite a workable situation or solution. It's relatively high embodied carbon, although the global warming potential of EPS foam is coming down. And then there's the exterior, the panelized system, which we're using at Sundance and SSRIA. It's faster, less time on site, less demolition waste. All the same advantages. We've got a continuous air vapor barrier, vapor control layer, high R value. We're adding about R30 to these walls. But it's so far, it's a little finicky. Fit is critical. You spend a long time prepping the buildings, making these offsite panels. They come, the windows are installed very carefully and in a thermal bridge and airtight way. And if you have a panel that doesn't fit, well, you've got a crane and a crew of 6 or so. It could be super expensive. I'm happy to report that so far, every single one of our panels has fit very nicely, and that they're actually getting better all the time as we practice with this. It's not necessarily less expensive yet, but I think it can be. I think of all these approaches, it has the most upside for innovation and mass production. So we need some kind of digital capture, like measuring with tape measures is just too error prone and slow to do this. And on the SSRIA project here, we're working with a brilliant young programmer who comes from the gaming world, and he's developed a photogrammetry app that's working really well. He starts with drone-based photos. Drones, not just because they're cool, but because you can get the optimum angles from a drone. You can photograph basically from anywhere and kind of get that perfect angle for good resolution and the right place to screen out or to poke behind that tree, that kind of stuff. It produces he smooshes them all together into a pixel cloud, which is kind of like a panoramic photo except 3D, and he takes 3 measurements from each of 2 sides of the building to make a big triangle, and then feeds those measurements into his pixel cloud and resizes it so that those measurements are what they are. And at that point, he can take measurements on the far side of the cloud, on the far side of the building where he's taken no measurements, and be within about 5 millimeters. And then he sends us a SketchUp file or a SketchUp readable file that we can then turn into panel drawings. So the other approach, which is a little more elaborate, is what we did at Sundance, where we hired a company to do a really smart surveyor to do a laser scan, actually 55 laser scans of the co-op to get the whole thing, and then he registers those together so that it's one big cloud of points, about 180 gigabytes, subtracting duplicates and resizing it according to some total station measurements, and sends us a cloud file that he clips out of the big cloud, one for each building. And then we bring it into SketchUp using a program called Undet, which finds planes and helps us extract the geometry of the building. And this is a fair bit of work, and because the buildings aren't level, square, or plumb, because nothing's perfect, and they've had 45 years to settle and probably weren't that square in the first place, we need to then sort of manually, judiciously fudge the geometry we've extracted to make it orthogonal, so everything's on a 90-degree plane. Anyway, this is working very well, but we'll be doing a webinar on how to do this, in which we present Logan's photogrammetry solution, along with a couple of different approaches to LiDAR scanning. So then, getting up on the roof, you know, the best approach depends on what you're starting with. The least expensive is probably to work from the inside. There are really two big considerations. One is airtightness. In many instances, you've got to usually you have to suck out the attic insulation, and the insulation. So far we haven't found insulation contractors who will reuse it. So that's kind of distressing, but you clean out the attic and then put down a layer of spray foam that seals all of the existing penetrations, and then put insulation back in. And that is probably, wasteful as it sounds, still the most economical solution if the existing roof structure is built in a way that you have high enough heels at the corners to accommodate enough insulation to deal with that cold spot. So in one of the SSRA houses, we have that, and that's what we'll be doing. In the second one, we don't have enough roof structure to accommodate enough insulation. It's a 1950s semi-bungalow, 2x4 framing. Very hard to get enough insulation in there to get us into net zero energy territory. So we're going to wrap the existing roof with an air barrier, and then build up with site framing a cavity big enough to keep that air barrier warm and above the dew point, and add enough insulation to get us up into the sort of R60 territory, which seems to be kind of a sweet spot. And in this particular case, we're also adding a porch that brings the house sort of fits it into the neighborhood a little better than it did, even though it's been there for 50 years. It's not bad, but the owners want to do that and take advantage of this opportunity to really spruce it up and add some amenity. So we'll be, because we're doing that at the same time, this built-up approach makes even more sense. And the third approach, and this is what we're doing at Sundance. There, the heel heights were low. The existing attics were very leaky. There wasn't much insulation in them, and we're building a whole new scissor truss structure over the top. Um, and that's another consideration in figuring out the roof buildup. Like in the in this situation here, we've had to be very careful to make sure that the existing roof can handle the additional load. Um, and you know that really needs professional advice. Don't try this at home without it. Um, but in the Sundance case, we're putting an entirely new load-bearing structure over the top, so the load staying where it is on the walls, and we can add another R50 over the top. So in all of this work, air tightness and air and water sealing is critical. Air leakage is the biggest single component of heat loss in most older buildings. Um, in the Sundance example, the buildings we tested were coming in at about 3.5 to 4 air changes an hour under test conditions. And we've gotten that down to 0.6, like not quite passive house territory, but the energy savings from that tightening are a big chunk of the value proposition. And that takes attention to detail and figuring out all of the junctions between the walls and the roof, walls and the foundation, in the walls to windows, that kind of thing. These are solutions that are, you know, familiar to any net zero builder, and that need tweaking for retrofits, but we're up to it, I think. And we also doing rain screens on all these buildings. Like with the rain screen, nothing is perfect. Like this is very durable siding. It's hardy siding, but but in a real driving rain, it's possible to get a few drops coming through. With a rain screen, that water can drain harmlessly out to the bottom, and it also makes it easier on the paint if there's no big moisture differential between the inside and the outside, and so you really enhance the durability by you know, well-designed rain screens. The fiber cement siding is great too. This should be like a 50-year proposition with maybe just a couple of coats of paint in the middle. So anytime that you tighten a building up, you have to add an HRV. We humans need fresh air, and I haven't built a house since the 1970s without an HRV. In fact, I made my first 3. But they not only provide a controlled supply of healthy fresh air, but they also extract they keep you from wasting the energy that is used to give you fresh air. The outgoing stale air preheats the incoming fresh air, and it's always worth it to spend a little more for a high efficiency HRV. It's, you know, on a dollars per kilowatt hour per year saved, higher efficiency is up near the top of the list. But putting HRVs in existing buildings it can be challenging, and you've got to get exhaust ducts up to any second story bathrooms, and all the bathrooms and the kitchen. Usually the main floor is not too bad in an unfinished basement situation. And at Sundance we got lucky. It dawned on us that we were pulling out the existing gas chimneys, and that we could use the chase for that to run a duct up to the attic, and then hop over in the attic to the bathroom ceiling. So we had zero drywall repair to get that to the top. No paint, no nothing. And so, you know, sometimes you get lucky. So we are, you know, we're improving reducing the energy load on these buildings enough that electrification can make sense. We have to basically electrify. It's one of the key tools in combating the climate crisis. And so this lets you go directly to air source heat pump heating. And because the loads are so much smaller, these things work. Like I would not put one on a house without doing a deep retrofit to it. They provide 2 units of heat on over the whole season. They'll give you 2 units of heat for every unit of electricity you put into them. Now you're paying more per unit of electricity than you are for gas, about 4 times, but you've also really reduced the total amount of energy. So when you start to consider carbon tax avoidance and the avoidance of the fixed monthly meter charges, you're in the black. But there's some things you need to keep in mind, because and I think it's going down to close to -30 here in Edmonton tonight, because when they get below -30, their efficiency drops off, where you might be putting in more than 1 unit of electricity for each unit of heat you get out. And because they have to work really hard to keep you warm when it's -30, we always put in Edmonton anyway. You don't need this in Vancouver and maybe big chunks of Ontario, but in Edmonton we need to have a backup electric resistance heater that takes over, and a control system that takes over when the temperature gets to where the heat pump doesn't make sense. And this also means that your electrical service needs to be sized to handle that electric resistance load, plus the load from electrifying hot water as well. Sometimes that means going to 150 or 200 amp service, and most houses have only 100. So that's a consideration. And as we get successful at doing this in the tens of thousands, we may run into issues on the grid capacity to supply these increased loads. The hard part is that it's only for a few days, a few hours a year that it's needed. The rest of the time, we're not drawing very much. But the utility needs to size their service so that it handles the peak draw, and they charge for it too. So on a big building, that can be a wake-up call. But so there are a zillion more details that we could go into, but I want to kind of jump back a little bit to the big picture and where we go from here. And so we get people asking us frequently, and more these days, what can they do with their house? There's a real lack of information and guidance, and the result is these piecemeal upgrades that I'm complaining about. We need a retrofit roadmap for these folks and for the contractors and consultants that they're going to need to do the work. And in my in our vision, it works something like this. We start with a gallery of case studies, fairly high level. So I go to the site, I find a house similar to mine. Okay, there's a 1950s semi-bungalow in Saskatoon. I can see they did a deep energy retrofit. There's the before and after. It cost them about $115,000. Whoa, that's more than I hoped. But when I look at their total cost of ownership, they've got it paid off in a reasonable time, and then they're laughing because they're not paying carbon tax, and their house is operating pretty much energy cost free. And here are the details on how they did it, with a deeper dive. So, and wow, it really looks great. Like I would be proud to live in a house like that. And it's so much better. So at the homeowner end, that's what we, it kind of says, okay, so what do I do now? And so then the next step would connect them to a network of energy advisors, designers, and contractors who know how to do this stuff. And there would be resources for those folks on the site as well. Energy model, the case studies would have energy models, upfront carbon tallies, details, drawings, successful techniques, hopefully mistakes to avoid. Sometimes you learn more from people's mistakes than you do from their successes. Total cost of ownership and links to incentives, and from there, hopefully proceeding to building projects. And the library of solutions, like this is a list. I don't try and read it. It just that just off the top of my head needs to be available for people trying to do this work. Um, we're we're starting to generate some of those, but we really need help. The the idea is that as we collect case studies from people, that we will be able to get their favorite details, ones that work, and we can have a database of solutions for various conundrums that people will run into. And it looks long, and it's going to get way longer as we go into other building types, but it's nowhere near infinite. It's not crazy. When you think that many of these solutions will be applicable across building types, different types of buildings, we're hoping that by using it strategically for various building types, you'll be able to quickly extract a recipe for that particular building. And this is all open source. Like we really think this is a missing critical practical step in building this industry, and we're committed to providing it. But we need help. And the roadmap itself, that graphic on the left, it's a jumble. It's complicated. We're hoping that we can turn this into more of a dashboard where you only see what you need to see, kind of like a car navigation screen where you don't see the suburbs until you turn off into that suburb, so that it's user-friendly both for homeowners and for contractors and practitioners. And I take some encouragement from our experience with net zero energy housing. We built the Riverdale Net Zero project, one of the first net zero houses in Canada under CMHC's Equilibrium program back in 2007. And this is an image of the mechanical schematic that we came up with. And I remember, and we built the darn thing, and it worked. But I remember the morning TV host who came on the tour and came into the mechanical room and said, she looked at this thing in horror, and like, I thought it was beautiful. All this gleaming copper. I just wanted to put a little TV down there and hang out with it. But she said, "You're not going to put this in people's houses, are you?" And I thought, lady, what do you know? Turns out she was dead right. But the encouraging thing is that by our third house, we were building houses that were simpler than existing houses because we'd reduced the energy load so much that we could get away with an even simpler mechanical system. So I'm hoping we can follow something like that. It probably won't be quite as dramatic, but that by working together, we can solve the problems and make this much more routine. So our next steps, we're going to establish Retrofit Canada as a national entity. We've got some really impressive board members who've just joined recently. We're currently test driving templates for intake for the gallery, so we can start populating the website. We're starting to develop version 2.0 of the retrofit roadmap. It won't be quite the fancy dashboard version, but we've gotten some funding assistance from EcoTrust to take it another step of the way while we look for the funding to build the app. And we'll continue the webinar series with deep dives into some of these topics that I just barely even scratched the surface of. And we're really hoping that for your help and cooperation and collaboration, that we can learn from each other, teach each other. I think like it's an emergency. We have to. And so it would be great to, if anyone has any questions, to go into that kind of discussions. I'm going to stop sharing my screen here so that I can see what's going on.
Hi everyone.
Thank you.
So we've received quite a few questions in the chat. I've been posting them in the Q&A. If you have access to Teams through the app on your computer, then you should be able to see the Q&A. And then if you like a question, you should be able to see it and give it a thumbs up. Or yeah, you can give it a thumbs up. That'll help to let me know which questions people wanted to hear answered most pressingly, or think is the most interesting. So I'm just going to start off the Q&A with you, Peter, and ask a question. Not sure how many people have access to uploading these items. Do you want to stop sharing your screen, Peter?
Yeah, I better figure out how to do that. Oh yeah, there we go. That's easy.
Okay, here's probably a quick, easy one. Are you doing EV charging stations at Sundance?
We did install. They're not in yet, but when we had to do an entire electrical upgrade, and we provided for 4 EV charging stations.
Awesome.
So we had to directionally drill all over the place to install a whole new electrical system, and while we were at it, we ran lines for some chargers.
Let's go. Here's an air source heat pump question. Are you always doing heat loss calculations for your air source heat pumps? Do you vent to the exterior?
Absolutely. I don't make my breakfast without a heat loss calculation. It's like but for sure, don't do something like an air source heat pump without it, because you need to know that that it's sized properly. And typically, when you put in a furnace, they often get oversized just to be on the safe side. You don't want to do that with an air source heat pump.
Perfect.
But I would do a whole built energy model, and then you might question whether the air source heat pump is the first thing to do, or whether it's something you do as part of a package.
Right. Typically after insulating an air sealing.
Yes.
So we have a few questions about the cost of all of this. And I think that's going to be a big ticket item for us to address as an organization. Can you ballpark what the cost of that chainsaw retrofit in Ritchie was compared to the panelized versions that you're doing now?
It's hard to do because the Ritchie retrofit was a few years ago, and the homeowner did a lot of the work himself. So that's difficult to do, and we're just in the process of finalizing the cost uh, of the three house SSRIA project, but the price will be definitely north of $100,000.
Yeah, and hopefully by the time this rolls out, there will be significant financing. Right now, at least people are able to apply to HERA and the Greener Homes grant to subsidize some of the costs of this on their homes, right?
Yes, I think that subsidies are going to be a key part of the business case uh, until we drive down the costs of some of the measures.
Someone was asking um, what you're doing right now to consider embodied carbon in the building material.
So that's a really good question, and I'm glad to I thank you for it. So embodied carbon is a big deal. The calculation and the reckoning of embodied carbon is hitting the building energy efficiency industry like a ton of bricks. We're realizing that the energy that gets spewed up into the atmosphere on day one, just from the materials that went to build that building, can often put you in the hole for 20, 30, 40 years. That a low carbon, relatively inefficient building might be better for the carbon emergency than a high carbon, super energy efficient building. So, but retrofits are golden. The greenest building there is the one that's already built. And so we're working hard. One of the reasons for using cellulose and wood as our primary building materials and insulation materials is because it is low carbon. So Mark Carver from Enercan compared what we're doing at Sundance with a project in Ottawa that used a foam panel, and they were both light years ahead of rebuilding, with the Sundance project being ahead of the foam-based project. So does that answer the question?
I believe it does. It's nice to have people ask their own questions sometimes because then they can respond
Yeah,
to
no,
your.
yeah. We're just figuring out working with this format. We'll do some research for the next one.
Um, so we had a code question, and so the question is, what? This seems like it makes a lot of sense for homes that already need this entire building renovation so that it can persist into the future, like the example you gave with the home in Ritchie. Um, what about homes that are being built to code minimum standard today? How how are they ever going to achieve net zero emissions?
That's a good question, and I don't have a good answer. Like, um, where, you know, to some degree, this is a leap of faith, and my, so my imagination, my imagining of my vision of the development path is that we start on the buildings with the biggest energy upside. We get good at those. We do those first, which helps, you know, turn the bathtub tap down. And that by the time we get all of the ones that are more, that are easier done, we'll have some kind of brainwave that helps us deal with with the ones that meet the current code. But for heaven's sakes, stop building to minimum code. Like that, they are the hardest buildings to fix. They've got good exteriors, windows with lots of life. The only problem with them is that they use way too much energy, and they're usually using too much for electrification. Um, it's a collective problem, and it's again, we can't do it all at once anyway. I think we got to start with the ones that we can do.
That makes sense. And to tie into that, there's been some delays in Canada's renovation code, increasing the standard for that, and also Canada's building code. Do you think there's any way that it could be net zero minimum before the current targeted date? Is it is there a
Well,
targeted date?
there is a targeted date. The idea is that the tiered code that's being worked on right now would have net zero ready. That would be an envelope that could be net zero. All you need to do is add the PV by 2030. That would be the crappiest house you could build. Um, and because that's what the code is a minimum standard. Uh, there's some pushback and argument about where that should be. I hope it doesn't delay the rolling out and the acceleration of the code, but it can't happen fast enough in my opinion. This is an emergency, and I think that it's an ongoing. There are lots of discussions at the policy level about what needs to be done and who should be listened to.
Absolutely. Um, we had a question about the photogrammetry and what energy modeling software you're using. Do we have a date slated for that webinar yet?
We haven't yet, but I I think we should be able to. I need to. I want to collaborate with the guys in doing the scanning for the Ottawa Community Housing Project, so that we have three approaches in the webinar. So we just need to coordinate with them. But I would say, February at the latest. Sorry, what was the first part of that question?
Someone's asking about energy modeling software. So I'm not.
Yeah. So we're using Hot 2000. My colleagues at Renew Engineering use IES, but I find that Hot 2000 is plenty good. That the results are very, very similar. It's a little bit easier, and it has the virtue of being the kind of test for EnerGuide rating. So it's tied in with this network of national energy evaluators and home labeling that's getting to be used more and more elsewhere. So I'll stick with it, and I think there's some exciting work happening to make it easier to use, and it's free.
Yeah, the free factor is definitely important for scaling this out, I think, if you want more people doing it more quickly. I've got a slew of questions in the Q&A. No one has really been upvoting them. So do you want, for our last question, we've got, I saw a good one over here. Oh, boy, there's too many questions here. Have you ever had any issues with moisture on the interior of the wall assembly because of a double vapor barrier?
So we're being careful not to install a double vapor barrier. It's a bad idea, although we do have it in the Sundance attic. But because the new vapor barrier we're installing has so much more insulation above it than below it, we're confident that it will stay warm enough not to present a condensation risk. But it's something you have to be very careful about. And because most houses have some kind of interior vapor retarder, whether it's a gazillion layers of paint, um, or so it's really part of the analysis in planning the project.
That makes sense. Mold and water damage kills homes, so
Yeah. Generally speaking, when you're done, you've got a better situation than you had before. Like it's safer, more robust.
I've got a question. I've got two questions for you, and I think we're gonna have to wrap it up after that. Um, I'm sure these people would love to pick your brain all day. At least that's what I'm getting from the amount of questions I'm seeing in the chat. Um, so, Energy Sprong in Netherlands, it seems like they're using exterior pod of mechanical equipment to accommodate all of these new changes to the buildings. And just given that our climate is so much colder, do you foresee this ever being a possibility so that homes where they don't have space, perhaps, they could accommodate the new mechanical?
I so the short answer is yes. But most of so they don't have basements in the Netherlands. They would be very rare. I mean, you dig a basement in the Netherlands and you have a swimming pool. That I mean, I'm exaggerating, but most of these buildings that they're doing have just crawl spaces, and so that's really the only way they could do it. And they've also are doing them at such a scale where a pre-manufactured mechanical pod that parks outside the building makes a lot of sense. We have basements. It's a lot cheaper to plug the indoor unit of the air source heat pump under your existing furnace and use your existing ductwork, and then somehow finagle away for the HRV. So it's possible that for that there will be enough buildings to make sense of a mechanical pod, particularly in multifamily. But it's not something that we're working on at the moment.
Do you want a doozy of a question, or do you want to end it there?
I'm happy to do a few more. They're great questions.
Okay. This one's kind of a doozy. What are some key policy requirements to accelerate the pace and affordability of deep energy retrofits across Canada?
Well, a carbon tax with an equitable, a higher carbon tax, something like the real cost of the energy transition, with a very robust equity safeguard would be the one thing that I would, and then I think we can sort it out ourselves. In the absence of that, I think incentive programs. I think that what we're doing with Retrofit Canada by trying to create a community of practitioners who will accelerate the finding of economical solutions. I think having the existing network of subsidies and that are available kind of reorient toward deep energy solutions. Like in my little world, I would like to say, okay, we'll do your energy audit, but you have to get the energy evaluator to spin the dials to a net zero solution. You don't necessarily have to do everything, but you have to know what it would take to get your building to a zero carbon solution before we give you a penny. And then you can go out and do any incremental thing that you want, but you have to know.
Yeah, lots of information homeowners need. There's a question about roofs. You want to talk to that, or?
Sure.
Um, so I'll ask my question. Um, is there how high do roof heels need to be so that you can just add the attic insulation within the interior? Is there like a minimum amount of softening that needs to be there?
Well, I think this is kind of an ongoing discussion. Um, 4 inches is a very common kind of 1970s, 80s heel height, and that makes me nervous. Now, if you fill that with spray foam, you could still get, say, R24 in there, really a little bit less when in the cold weather. So you don't have a condensation risk. Um, and if you added more insulation somewhere else, you could probably make up the heat loss. But you would be completely blocking off any opportunity for attic ventilation. And so you'd have to introduce vents higher up above the heel, vents that are typically would have been in the soffit. And so those can be unsightly. Also, they can take up space that really you might want to put solar panels on. So it's kind of a moving target. It's something we really need to fine tune and optimize. I would, if you can get it up to say 6 or 7 inches, which is not uncommon in 50s houses, they have a 2x6 ceiling joist and then a a 2-inch rafter after the bird's mouth, then I think it's workable.
Another question. What's your opinion on air source heat pumps?
Pardon?
What is your opinion on air source heat pumps? Oh, air source water heaters, excuse me.
Okay, so air source water heaters paired with air source heat pump heating systems are absolutely the way to go. So they heat water by cooling the space they're in. So they're wonderful in a cold room. It's counterintuitive that in Edmonton, when it's 30 below, you would cool your house for anything. But what ends up happening is your air source heat pump works a little longer to recover that heat and keeps you comfortable. And paired together and calculating the efficiencies of both, you get an annual performance of somewhere around 180% efficient. So you're getting 1.8 units of hot water for every unit of electricity you put in. And that's pretty good. It's way better than the one that you would get from electric resistance. So we put them in all of our net zero. It's part of our net zero recipe now. And uh-oh. Sorry. Yikes. I'm trying to kill it here. He'll go away. There. I didn't turn off my cell phone. I'm sorry, and it answers through my computer. I'm sorry. Anyway, the so their air source heat pump water heaters are definitely the way to go in these projects. We've had really good luck with them. They work well, and you just need to occasionally in a very small space you have to duct the return air to your main heating system through them, so that it distributes the cold air that just got the heat sucked out of it, so it doesn't make you uncomfortable.
There's a question about heating a home with electric radiant heating. Do you think that could supply full heating loads or supplement?
So electric radiant heating is 100% efficient. Every unit of heat that you get out, you can measure heat in kilowatt hours, just like calories or watts or anything else. For every kilowatt hour of heat you get out, takes 1 kilowatt hour of electricity in. The air source heat pumps, on the contrary, or by contrast, can give you 2 units of heat for every a unit of electricity, so twice as efficient. And a geothermal system, which may not be practical in a lot of situations, a bigger upfront cost, can give you between 3 and 4 units of useful heat for every unit of electricity, because you're drawing off this huge thermal bank, the Earth.
Would you know approximately the longevity of each system?
So the from what we're hearing, we haven't had any of these systems long enough to know what their upper lifespan is. What we're hearing is that it's about the same as a furnace. And the geosystems, the geo part of it, the drilled, the loops in the ground and all that kind of stuff is pretty much from. It's really cold for there to be birds out.
It's my phone. Also not muted. Well, it seems like that was a good answer. And there's no more questions, at least none that I can see. So
okay, well, we went to the end.
Yeah. So
well, thanks everybody.
Yeah, thank you everyone. If you're interested in following along, we're going to send a short survey out to everyone. We encourage you to follow us on social media. We're on everything except for Twitter, I think. So that's at Retrofit Canada. You can find us online or our website, retrofitcanada.com. We're hoping to have another presentation in the new year. We're hoping to offer one to teach people more about Sundance and how they rationalized everything as a cooperative housing organization. And then we'll have one as well on the photogrammetry and other ways of doing digital capture for these buildings. Okay, thank you.
Okay.
Now, how do we end it? Do we have to leave?